some pre-processing of the data, and then we introduce our distributed segmentation algorithm. It's scaled for the data based on the data amount, and then from that output we try to identify the different segmentation, and finally we get the consumer profiles. So as I said, we identified segmentations of the customers in 3 main steps: annually, weekly, and daily. And this is to give an idea about how big is the data. So at start, all 60 million data points are in the single point cluster, and then we removed the outliers and did the pre-processing and got this interesting Milky Way like pattern. And then we ran segmentation on top of that, and this is the results we got. You can see there's a clear segmentation, like, and there are like not only there's a clear segmentation, but it also captures the seasonal variations as well. That's it on AGL project. This is another project we are doing collaboration with University of Aalto in Finland and Siemens Finland. And we are doing this project as a case study as a using Finland markets, automated bidding on frequency reserve markets. So the idea in this project was at any time there's a gap in energy generation and consumption. With the current trend of moving towards the alternative energy resources like solar power and wind, this gap getting higher due to the reason that these energy resources are very unpredictable, and we need smart method of storing energy. So frequency reserve markets exist in purpose of this. So there can be like multiple markets where we individuals can buy or sell their energy and make profits, and also reduce the gap in the global grid in energy. So for example, if you have like a electric vehicle and you have a fully loaded battery, and you don't need that in next few days, you can sell in one of the market and make profit, and also reduce the gap in energy generation and consumption. So this is kind of similar to stock market analysis, and we need to predict the future price of the markets to identify which market is suitable to bid. So for that we can use AI algorithm, but solely using future price prediction we can't do that, because AI algorithm is like a black box where we input set of data and get a prediction, but we don't know how confidence about the AI algorithm about the prediction. It may give in a random output. For example, if we train an AI algorithm with set of data, it try to capture the data patterns in that AI algorithm try to capture data patterns in that data set, and then in the testing time when we insert a new set of data, it try to predict prediction, and if the new data set have the same patterns as the old data set, it may give a good results which are actually similar to the actual results. But if this new data set has completely new data patterns, then it may be giving a random output, and it do not have a high confidence on the results. So we can use another parameter to identify this, called uncertainty value. This is a somewhat fairly new area in deep learning research, but quite old in the statistics side. And current AI researchers trying to combine these two and get a prediction and uncertainty value for each predictions. So this is the approach we have used for this one. So we are using state-of-art deep learning based method to predict the price, and latent space representation to get approximation of the uncertainty. That's it from me. I'll hand out to Dr. Dustin to carry on with.
Thank you, Timal. Good evening, all. How are you feeling? Cool. That's one strongly expressed emotion. In terms of content, are we intelligently, artificially saturated? I have the risky position of being the only person standing between you and a solid kottu feed or a hopper feed, perhaps. So is it all right if I continue at the same pace, or should I rush this last bit, knowing that dinner is also quite important? A show of hands if I should rush. Oh, that's good. Happy to continue at this pace. All right. So you heard about the industry verticals and that transformation. So if I ask you to recollect, the title of this presentation was Transforming Academic Research into Industry Innovations. And that's what we have presented so far in terms of 3 industry verticals: smart cities, digital health, and energy. And my focus would be on a bit of discussion on how we attempt this, and I will start by asking you to recall data flow diagrams from maybe 1 decade or 5 decades ago, depending on how old we are. So this is a standard input-output diagram, and what generally happens is that most academic research, or the conventional academic research approach, is to stop at the output column or layer and not really progress towards the outcomes or the actual impact of innovation. So I am proud to be part of a center where we have actually demonstrated that the output can actually be transformed into outcomes, and also more towards the actual social or economical impact of that AI innovation. So I'll quickly go through the 5 columns. The brain has 6 columns, but this diagram has only 5. So with the input, we have the first key element, which is human capital, and that's familiar territory for any academic research outfit or an industry research group. So honor students, master's students, research assistants, PhD candidates, and that has to be supported by an institutional platform. So there has to be the infrastructure, technology, utilities, and so on. Access to published research, so you need to have access to some of the subscription-based libraries. That's a whole business empire altogether, but a discussion for later. And then there's also sources of direct and indirect funding. And coupled with those two, we need academic leadership, so research staff, full-time, part-time research fellows, lecturers, professors, and so on. Then the background IP, so the foundational work that supports the new work that is to be done by the human capital, and also supported by the publication track record. So most research endeavors have some parts of this. But what's generally lacking is that industry partnership. Either the industry partner is present just for namesake and not really involved in the project. It's a bit of a social responsibility or corporate social responsibility from the industry point of view. So they have to come with the real world problem, the real world challenge, the domain expertise, and also potential funding that can be a top-up for the scholarship and so on. So what happens in research is we transform these through various activities. So the technical activities which we are all familiar with, lit reviews, data collection, experiments, analysis, and so on. But there's a little bit more to the activities. So academic engagement, so this sort of discussion forum where there is an exchange of ideas and there's questions asked and potential answered explored. And also things like mobility programs, as well as the conference attending and the conference organizing. So there is a bit of scale in that approach where you start with basic discussions, workshops, and then you build that all the way into conferences, again attended by academics and individuals from industry who are interested in these. And AI, fortunately, and also analytics is a strong area of this kind of scaled development, from workshops to conferences, and conferences where even industry gets involved in making offers of employment to PhD candidates. And then there is international engagement, so membership of societies, say the IEEE. In this instance, I assume there's quite a number of members, senior members, or even fellows of the IEEE in the audience, committees, and also standards groups. So you gradually work up the scale. And then from industry partnership, you can also get into industry engagement, so domain expertise, community links. So industry transforms that research into something that's useful for the community. And then you have the outputs. So what's the academic favorite are publications. We generally stop there because that helps the university ranking, and there's also a bit of ego boost in having your name on as an author on papers. So there's conferences, journals, there's open access, there's reports and blogs, and there's lots of, say, Medium type articles that are produced. And then there's new IP inventions, patents, which leads to new funding. So internal, national, and international grants. And then also fairly important because in our experience, we had some of our energy work was read by a research group in Norway who've contacted us, and they're sending one of their PhD students for a 6-month internship with our center, mostly through the publicity about the LEAP project that you heard from Thimal. So the output has to be transformed into outcomes, and that's where there is perhaps a bit of a deficiency or a gap in most academic research. And that outcomes, those outcomes can form commercial outcomes, so products and services that are licensed or subscription based. And being in the technology space, it is quite easy to transform your academic research into a subscription model, your algorithm into a subscription model, saying compared to life sciences or say certain engineering disciplines. There is very low overhead to that transformation process. And then scaling up from there, you can have spin-offs, startups, joint ventures, and also the academic outcomes are that you work your way towards journal editorships or edited books or authored books and so on. And then finally also there is quite a significant part for academics to play in this space of informing policy, developing policy, and also extending policy. So that's a collaboration between industry and academia. And we see that eventuating a fair bit in Australian context, and hopefully that Sri Lanka will also move towards that space where academics actually listen to in the development of policy. And then finally, the impact of innovation is where there is an actual value addition to society, to the economy, culturally, by improving the quality of life, and also more recently the importance of sustainability and the environmental impact, or reducing the environmental impact of human societies. And then extending from that, the reduction of risk in decision making, having more research-focused, research-trained, critical thinking workforce, expanding a market for different kinds of new technological services, and also job creation in that context. So I would like most of you or all of you to think of research in this context. So it's not just inputs and outputs. It's not that limited data flow diagram. You actually have to transform your output into outcomes that actually lead to an impact towards society and the country at large. So now I will ask you to channel your neural network lessons. So that's a feed forward. And maybe we can add a bit of a backpropagation there. So before you start even thinking about the title and the abstract of your paper, you can always think about the impact of this paper to broader society. Am I actually contributing in any form to the advancement or the upliftment of, say, quality of life or economic impact, social impact, and so on? And in the midst of that, you can actually look at a bit of an LSTM, so the expanding or the exploding gradient or the vanishing gradient. You can solve that part as well, where you can map your outcomes into output and your output into activities and so on. And closely aligned with this kind of backpropagation is that you don't try to force an algorithm on a problem. You try to understand the problem first, and then you think of which algorithm will actually work or successfully solve this problem. So if you start at the pointy end of this landscape, then you can find the really good solution that fits the purpose and really adds value to the context of that problem. So we started with data flow, we looked at the feed forward, and there's also a backpropagation. So if you have that in mind, I think research can actually be transformed into innovation with impact, and that impact is across the board in different contexts, as we see there. All right, so we would like to think this is not only a tech talk, it's also an invitation to collaborate. So I assume there's a good cross-section of the STEM space, the technology space in Sri Lanka. So industry, academia, students, and anyone who's generally interested. I wouldn't really have to mention why this is so crucial at this time of day, because AI is ubiquitous. I mean, it's everywhere, from your smartphone to the smart cities to sensors, smart grids, and so on. And it is the start of a new decade, so AI will effectively define this decade, and it is good to start early, and we are already 7 days into January, so you've started already. And CDAC, along with data search, have there's 6 reasons. Academics usually deal with 3 reasons, but I'm giving you double that. So there's 6 reasons why I would strongly encourage you to come and talk to us and build this bridge with industry. So link up with industry alongside the academic research and the transformation of academic research into innovations with impact. And just to get the thinking started, perhaps a few ideas that you can think of as you have your Hopper feed tonight. So a bit of a disclaimer, I'm not trying to step on your toes, or we're not trying to provide unsolicited advice on how to run your company or how to conduct your research. Just a few ideas throwing in there. Sri Lanka has a strong international reputation in technology development. So there's so many software development organizations, and there is a strong opportunity in embedding AI into technology design. And it's very, there's only limited research in this space, because any AI researcher is always in the mindset of algorithm, dataset, algorithm, dataset. They don't really think of the infrastructure supporting the algorithm, or where as the data is collected by the system, the AI actually generates the intelligence. So that self-generating, self-structuring artificial intelligence can actually be designed into the technology platform. And that's where there's a bit of food for thought there, where if AI can be embedded into technology design, then quite a strong innovation in terms of what you already have as an international player in the software development space. extending from that, you can actually integrate ethics and data governance into those technology platforms that you build. So data governance is becoming increasingly important. You actually cannot talk about AI without talking about ethics now. So if you can have the checks and balances for ethics and data governance incorporated into these technology platforms, then that again will be an international bestseller. So there isn't much research in this space. There isn't much industry-focused development also in this space. Again, prime for new ideas. And then from the data perspective, if you can actually extract the data in an anonymized, non-identifying manner, and if that can be analyzed for insights generation, which is all still part of the technology platform that you're building, whether it's a library, a piece of software, a piece of code, that would also be quite novel in terms of how you can leverage your international reputation in technology development. And then there's also the opportunity to augment the data sets that your customer already has. So they're collecting some sort of data about their customers, about their competitors, about their processes, and so on. And on the other hand, there's lots of open source data, publicly available data, social media or competitor analysis that can be, those two data sets can be combined, fused together, augmented and enriched for further insights generation. And finally, with insights generation, it shouldn't just be at the operational levels. You're not trying to improve just the process or just the technology platform that you're actually building. You should try to think beyond the operational efficiencies into, say, tactical advantage, strategic value, and so on. So the technology platform itself will be